Hey, welcome everyone to this tutorial. It's about VCV Rack, which is a free modular software synthesizer with over the 2000 free modules to download. So it's really something. I got a few questions, so I thought maybe I can help a few people to start with this program. First, we should talk a little bit about the most important settings of VCV Rack. First thing, every time we select to start a new patch, we get this same start screen. And the first thing we do is connect VCV Rack with the audio of our PC. We do that through this module by right-clicking and first choosing our driver. I suggest you choose one of the above two. They give you least latency and they perform the best. If you choose ASIO and you don't have any options here, you just have to download the ASIO for all driver. It's also free to download. But in this case, I will just choose Wasabi as the audio driver. And next, I'm gonna choose select my regular speakers. Alright, after we done that, in our starting patch, they already selected our computer keyboard as an input signal. So we can press just any keys to see if we get any sound yet. Alright, it works. Next, we do after installing VCV Rack is we best go to the library, and if you're not logged in yet, you get here the options to log in with the same account as the website of VCV Rack, and so you will always automatically get the updates. You can go to the library and select all free plugins, and when you start VCV Rack again, they will automatically install itself. So that's a good thing to know. Next thing is about the performance. Here we have three options. First one, performance meters. This is a useful tool to give us an idea how much a certain module or plugin takes from our CPU. So if I press that, at the bottom we can see the values, how much they take from our CPU. What's more important, after we get an idea how much a certain module takes, is that we always turn this back off before we're gonna listen to our sound, because this option takes way too much of the CPU. So we turn this back off. Next option is the sample rate of the audio. On this old PC from 11 years old, it works perfectly on studio quality 48 kHz. So I would leave it at that. Next thing is also important. Here we can choose how many threads we are going to use from our CPU. And according to the instructions of VCV Rack itself, it's very important to always leave it at one thread until it is absolutely necessary to go to 2. And you will notice when it is absolutely necessary when the sound starts to crackling. But for the rest, always leave this option at one thread. The next option that can help us, if you, for example, try to run this program on a laptop from 10 years old or something, You can put the frame rate at 36, excuse me, or 29. This will help a lot. So you will be able to build a lot more modules. Alright, that were the most important settings of VCV Rack. So next thing we do after we select our new patch, every time we have to do that again, is select every module, because of course we want to make our own patch, and delete them. Except this module. We always need this module to make the connection between VCV Rack and our audio. Alright, now how are we gonna produce any sound with a modular synth? Therefore, we're gonna talk about the three most important modules of a modular synthesizer that always go together. That are these three. The first is the most important one. I will zoom in a little bit. And this is called a voltage controlled oscillator, or in short, just an oscillator. And it sends out signals of a certain waveform. We're going through the waveforms very quick. The first wave, as you can see, is a sine waveform. So that's how it's called, just a sine wave. Our next waveform makes a perfect triangle. So that's our triangle wave. This one is not a common wave you're gonna find in every oscillator. So this is our third official waveform, and it makes the form of a saw somewhat. So it's called a sawtooth waveform. And our last waveform makes perfect squares. So we call it a square wave. So we got our square wave, our sawtooth, our triangle, and our sine wave. On this module, we have a few options to put our cables. And which one are the inputs and which ones are the outputs. As you can see, some options to put a cable have a black square around it. Those are always the outputs. Not every type of module or brand uses the same color code, but most use some kind of a color code. Sometimes they are gray, sometimes they are red, but most of the time there will be some kind of a difference between inputs and outputs. As you can see here, we have an input that is called volt/octave. What this means, everything in a modular synthesizer is controlled by voltage. The only thing you should remember for now is that 1 volt equals 1 octave. So that can be important. For instance, if you have 3 voltage going on, we have 3 octaves. If we have let's say a range from 0 to 10 voltage, we have 10 octaves. Alright. What's another thing to keep in mind and what can be important for the future is above we have the frequency modulation option. Not every module is gonna have a volt per octave input. Most of the time, for example, percussion modules, they don't have a volt per octave input, but they do have a frequency modulation input. If you put this knob with modulates the frequency, sets the range. Actually, it sets the range of the frequency modulation. If you turn this knob all the way up, it's the same as a volt per octave input. So in this case, if I put a cable in this or in this, it will be the same sound. That's something to keep in mind for example, percussion modules. That's the only thing you should remember for now. Our next module is our voltage controlled amplifier. As the name says itself, it's an amplifier, but it's voltage controlled, which means we can give it information how it's gonna sound. So let me zoom out again. Let me first tell you what this does. This is called an envelope generator, or attack, decay, sustain, release. You can compare it by pressing keys on a piano key, but not in the exact same way, but more or less it's like pressing a key softly, hard, keeping the key down for a time, and after you release the key, how long the sound is gonna stay sounding. And I choose this module so you can see the shape of the envelope. So we got our attack, our decay, our sustain, and our release. And as we move it, you can see the shape changing. Alright, first listen for a moment to the pure sound of our oscillator in the different waveforms. Put this a little bit down and listen to it for a moment. Alright, first we got our sine waveform, then we're gonna move it to our triangle. Now we're gonna move it further to our sawtooth. And now we're gonna move it even further to the square. So that's how a square sounds. A saw, a triangle, and a sine. Alright, now you have an idea how the basic waveforms sound like. So how are we gonna transform that annoying sound in something more interesting? Alright, let's make the connections. First, we're gonna go from our oscillator to the input of our amplifier, and as you can see, we have different color options we can choose for our cables. It can help a lot to make for your own a decision which cable you're gonna use in which situation. So in my case, when it is audio that's coming out, an audio signal, I use a red cable. When I do modulation, I use a green cable, and when it's just a trigger signal or pitch information, I use blue cables. But you can choose your own, of course. But it makes it more easy to learn and to understand everything. Alright, let's go on. So next, we give the information of our envelope generator to our voltage controlled amplifier, and we go to our output. Alright, nothing happens. Why not? That's because we have to trigger our envelope generator by something. Normally we do that via our gate or trigger input. But this one also has a push button, so we can briefly test it for a moment by pushing the button. All right. And now we can already see what this envelope generator does on the sound. So let's put this all the way down. You can see that the attack of our envelope generator closes or makes shorter. And as you can hear, it makes the sound harder, stronger, louder as we make the attack shorter. Now, if we make a very long attack, the sound will almost disappear completely. So that can be a bit confusing in the beginning. More closed is louder in this case. But of course you will have to experiment with the envelope generator yourself to get an idea how it responds. All right. So let's say if we put the release and the decay all the way down, we get more of a percussion sound. Now, let's demonstrate. You see, it's more percussion. Now the sustain, it's not like holding a piano key down, but it's a bit more like a sort of like a volume in this case. Let me demonstrate. All right. Now we have more or less an idea how an envelope generator responds. But of course, that's not enough. We're gonna want to give it some pitch information and some tempo. Or let's say some pauses between the notes. How are we gonna do that? Therefore, we're gonna use our next modules. The first one we almost always gonna use is our clock generator. If we look at this for a moment, we can see with this knob we can select our tempo or beats per minute. Just gonna leave it at 120. And we have some inputs, outputs. This one has a gray square around it. So this is our outputs. Those are our outputs. And we got 3 clocks. Clock 1, clock 2, clock 3. And with this, we can choose to divide our clock or to multiply our clock. So we can generate different rhythms within our patch. We also have a reset button, and we gonna connect almost every module that has a reset button. We're gonna connect with the reset button of our clock generator. It has a run button. This is just like a start-stop button, and it has a normal beats per minute output. So next module we're gonna need is what's called a sequencer. And what this does is telling which notes we're gonna give to our oscillator, and when our envelope generator is gonna trigger those notes. So actually, which notes we are gonna play and when we are gonna play them. As you can see, the sequencer has 3 rows. Those rows we can use to give pitch information to our oscillator. And at the bottom we can see the outputs of those 3 rows. And at the bottom here we can see buttons. With those buttons we can choose which notes we are gonna play and which not. So let's try, for example, this for a moment. So let's connect the pitch information from the first row with the pitch information from our voltage controlled oscillator. And let's trigger our envelope generator and see how it sounds like. Also, we have to, of course, give our clock information and a reset button. Reset. All right. It's doing something, but not much, because the attack was way too long. All right, now let's give it some pitch information. All right. We already got something. All right. That's already something. But now we are selecting pitch, but it's kind of random. Let's say if we always want to keep our notes in a certain scale. Therefore, we use a module that is called a quantizer. They almost always go together. This type of sequencer in combination with this quantizer to give pitch information. With this quantizer, we can choose our musical scale, our keys. I don't know anything about music, by the way, and that's something else that's very interesting. At Modular synthesizer, you don't have to know anything about music. In this case, let's call it, here we can choose our musical letters. And here we can use our scale. We can choose our scale. So, all right. And with the bottom knob, we can go an up octave down or up. So let's see what it does when we send the pitch information from our sequencer first through the quantizer. Let's see what it does. All right. And as you can hear, we already have something strange going on. If I put them a little more higher, it will be more obvious. But although we haven't selected these triggers, we can still hear those notes. How come? That's because the envelope is larger than the gate of our triggers. I can demonstrate by making the release shorter, and the phenomenon will disappear. And we got back only the triggers we've selected. But that's not what we want. Let's say we don't want those ghost notes. Therefore we use another module, which is called a sample and hold. What it does, it's sampling, it samples a certain value and it sends it out at a certain trigger. So in our case, we just want to capture this pitch value and sending them out only at this triggers. So let's do that by sending our pitch information first to our sample and hold, trigger it to our trigger, and sending it out to our quantizer. And now, as you can see, we make it as long as we want. They won't play anymore. All right. So that's one thing. Maybe go an octave lower. Maybe another octave lower. All right. Now give this sound maybe a little more color. So we already got something interesting going on by sending it through an effect. And let's see what it gives us. Reset. All right. It sounds pretty nice. Maybe a little bit less effect. And let's go through the waveforms briefly to listen how it sounds like. Different waveforms. And choose some different notes. All right. Now we got already something going on. Let's say make it a bit more interesting and duplicate this one, duplicate this one, duplicate this one, so we can have multiple sounds going on. Of course, we're also gonna have to put it through a mixer, of course. So let's use the second row. Let's connect it first. Use the second row. manipulation. All right, let's trigger it. All right, send it through quantizer. And maybe this one an octave higher. All right, and select a few notes. All right, and let's turn it to the mixer first. The input, output, going through the effect, and let's see how it sounds like. And let's choose a different wave. Maybe an octave lower. All right. But we still got a third row here, as you can see. So what can we do with that? Maybe use it to modulate, use it as a modulation actually. So you can see, I will give a demonstration. Let's modulate the attack a bit. And if we turn, as you can see, when we selected the pitch information, they are all turned to the right. That's because with this sequencer, when we turn knobs to the left, we go into the negative voltage and we can't hear them. So, but they are very useful for modulation. So let's give a demonstration. As you can see. And let's give the next one a positive voltage. It will go to the other side. This one back a negative voltage. And this one a positive voltage. So now we are modulating our attacks with this third row. Alright, that gives us already something interesting. Alright, what can we do next? First of all, we're gonna make sure we don't have any ghost notes there either. Alright, no more ghost notes. Next thing, let's say we want to make the sequencer a 4-step per beat sequence. So we get 4 steps for every beat. How can we do that? Simply by turning our first clock that goes into our sequencer and multiply it by 4. So now we get 4 steps for every beat. And listen how it sounds like. All right. Alright, now we got already something going on. Let's change the waveform. Alright. Now we got already something interesting. Maybe let's see what I got here. Alright, let's give it a kick. And how shall we trigger it? Maybe just by our normal clock. So let's trigger it by a normal clock. Clock times 1. See how it sounds like. Choose another kick. Maybe a bit lower. Alright, we already got something, but let's say we don't want our kick through this effect going. Therefore, we're going to use another mixer. Put this here, output here. And now let's put the kick drum in this mixer without going through this effect. And let's see what it sounds like. Alright, it's already a bit better. We already got something here. What can we do next? Let's say, let's give it already also a hi-hat. How are we gonna trigger it? Maybe a clock times 2 and send that through a Bernoulli gate. A Bernoulli gate is like chances. So if I leave it like that in the middle, it will 50% choose between each of those outputs. Let's demonstrate. Oh. Why can't we hear anything? Because we haven't connected it. This is without effect. Now let's put it through the effect. That's maybe a bit better. And now with our Bernoulli gate, we can choose how much open or closed hi-hats we want, so we get more variation. This knob, we can select the sound of our hi-hat. but as you can see, it's already pretty amusing to play with. So I've got here our last module that I have put ready for this first tutorial, and that is called a low frequency oscillator. We're not gonna go into detail yet because it's for one of the following tutorials, but I can show you what we can do with this. This module is most of the time used to modulate anything else, especially those parameters are most of the time modulated with a low frequency oscillator. In this case, I wanted to see if it is possible to let this low frequency oscillator slowly change between the different waveforms of our oscillators. And to do that, we have to put our low frequency oscillator on slow. We have to use our sine waveform. It has a reset button, so everything that has a reset button goes to the reset. And let's see how it can modulate the position of our voltage controlled oscillator. It doesn't do anything because we have to select how much it has to influence. And as you can see, it doesn't go all the way to our square waveform. Therefore, we have to offset this option, which means it goes from 0 to 10 volts, or in this case 0 to 5 volts, instead of -5 till +5. So now we get full modulation, but we want it maybe a bit more slow. Alright, let's duplicate this. Also reset it. And let's modulate it, our second oscillator. And make it maybe a bit more slow even. So we got some nice modulation going on between the different sounds. Maybe a bit more slow. Alright, I think this is a nice introduction to get you started with this program. And as you can see, it doesn't take much to get something very nice and pleasant to play with. Now, of course, you can put some buttons on or off. Alright, I'm gonna leave it with this for now, and I'll see you next time when we're gonna talk much more in detail about sequencers and modulation. So, but for now, thanks for watching and see you next time. Bye!